Alright, this is lesson 78, geometric sequences. Okay, we talked about arithmetic sequences, which is a set of numbers. So an arithmetic sequence is like 2, 4, 6, 8, 10. Next number? 12. How did you figure out that? You just added what? 2, right? Because the common difference is 2. Okay, so that's sequence. A sequence is a list of numbers, and then a series is when we add the numbers together. So it's like saying 2 plus 4 plus 6 plus 8 plus 10, right? We did that last week and this week. Remember doing that? Okay, there's a new one we're learning about today, which is geometric sequences. So just like arithmetic sequences, it's a list, except this is how it works. 2, 4, 8, 16. What's the next number? 32. How'd you figure that out? Multiply by 2. Did y'all get that? So an arithmetic sequence is you're adding the same number to the next number, right? 2, 4, 6, 8, 10. 12. Okay. Geometric sequence. 2, 4, 8, 16, 32. 64. You were multiplying. Did y'all get that? Okay. That's the difference. So we're doing the same concept. It's a list. We're going to be doing an explicit formula. We're going to identify if we have this, if it's a geometric sequence or not. Okay? Here are the steps. If you're on the video, you should pause. Is this working? There it goes. Pause the video here, and here we go. Watch me do numbers 1. Let me go back. Sorry, I did this first period. I want to just save this. Okay, here we go. Number 1, determine if the sequence is geometric. So the first thing I want to do is figure out what am I multiplying, or what common ratio am I multiplying from the first number to the second one. So from -1 to 2, I'm multiplying by -2, right? Because -1 times -2 is +2, right? And then what do I multiply 2 with to get -4? -2 again, right? And what do I multiply -2 with to get +8? -4 times -2 is +8. So then I ask myself, am I multiplying by the same number every time? Yes. So this is a geometric sequence. That's number 1. And I'm going to put parentheses around that because that's the common ratio, okay? So I'm always multiplying by -2. Our common ratio is -2 in this case. Okay, watch me do number 2. Number 2, I'm asking the same thing. What do I multiply 2 with to get 4? Or I'm sorry, 2 with to get... Is there 2 up here? Oh, I'm sorry. I'm blocking my screen here. What am I multiplying 4 with to get 12? 3, right? Okay, so 3. And then what do I multiply 12 to get 36? 3 again. And what do I multiply 36 to get 108? 3, right? Am I multiplying by a common ratio every time? Yes. So this is a geometric sequence. Okay, so that's the first goal today. You're going to tell me on your homework or on a test. It's a basic skill. Is it a geometric sequence or not? Yes or no. Okay, what I'd like you to do, turn your neighbor, explain. Couple. Here we go. Next one, number 3. Okay, write this sequence down. We have 4, 12, 20, and 28. And then after you write it down, ask your neighbor what's the common ratio if there is one, and then determine is it a geometric sequence or not. Once you have your answer, write it down on your whiteboards, and then I'll check up on you. I'll give you 20 seconds. Go. It's not a geometric sequence because we know that there is no common ratio here. Right? 4 times 3 is 12. So what's 12 times 3? I should really have 36 here, right? But I don't. I have 20. Okay, therefore it is not a geometric sequence. So no. Number 4, go by yourselves and then write your answer on your iPads. And when you write your answers, please tell me what the ratio is by saying the common ratio, or r is equal to what. Okay, go. So we're saying yes, this is a geometric sequence, and then you would write r is equal to 4 because that's our common ratio, okay? Meaning we're multiplying every time by 4, okay? Good, that's the first part of our lesson. So, next part of our lesson, our next objective is... What's going on here? Oh. Number 5, identify the explicit formula. Just like there was an explicit formula for arithmetic sequences, there's an explicit formula for geometric sequences. So right now you're just watching. This is the next part of the lesson. So the goal here is to find the explicit formula, okay? So this looks like just like number 1. So to find the explicit formula, we need to first figure out what our explicit formula, the form of it is. So this is in your notes, right here, and your steps. So we need to figure out what the first term is and the ratio. That's all we need to figure out to find the explicit formula. So we'd figure out, oh, okay, just like on number 1, the common ratio here is -2, right, every time. So r is equal to -2, all right? Then to write the explicit formula for this particular for this particular sequence, all we need to do is write a sub n is equal to our first term, which is -1, times r, and r in this case is going to be equal to -2, and then we write n minus 1. Okay, and actually it should say right here. Let me clean this up a little bit. R right here is -2, so we're going to put -2 here. Okay, so that's the answer for number 1. Okay, and I'm going to put -2 in its own parentheses because I want that to be there. Okay, number 6 now. Number 6, same thing. I want to figure out what is the common ratio, and then I want to figure out what my first term is. So I'm looking each time it's being multiplied by 2, right? Each time. So we start with a sub a sub n, or any term in our sequence here, is going to be equal to the first term, which is -2.5, or 2 5/10, times our ratio of 2, all to the power of n minus 1. Okay, this is a generic explicit formula. So we would say that our sequence, this is the explicit formula for any term in the sequence. Okay. So the n is still a variable. We're not talking specifics yet, but this is the explicit formula, okay? So, take 30 seconds to talk to your neighbor. How do we find the explicit formula? Please go through the steps and discuss. Ready, set, go. Continuing on, did you need time to write that last one down? Raise your hand if you need more time. Okay, I'm sorry about that. Number 7, we have 2, -4, 8, -16. So turn your neighbor and identify the common ratio with your neighbor. What's the common ratio here? Okay, what's the common ratio, everyone? -2, right? Okay, so start with writing a sub n, right? We're doing this one together. What's our first term? 2, right? So we're going to write +2 times our ratio of -2 to the n minus 1, okay? So write that down on your iPads and then check your neighbor's work. Make sure they did it correctly. If they did it correctly, just raise your hand. This one was together. Make sure that your neighbor did it correctly. Raise your hand if your neighbor did it correctly. Okay, good. This section, raise your hand if your neighbor did it correctly. You're basically copying what I just did. Okay, good. Number 8, by yourselves. Go. Number 8 is the following. A sub n is equal to -40 times 1/2 to the n minus 1 power. Okay. Oh, sorry, went too fast. That's the answer. Any questions on this section? So that's the explicit formula. You need to know how to make it. Whenever there is a set of numbers that's a geometric sequence, you need to memorize how this works. This is going to be on the test, so memorize this formula. Test will be a little while though from now. Okay, number 9. Okay, I'm going to show you a couple more problems. I need you to just watch right now. You're just watching, you have a chance to write. Okay, so now that we know the explicit formula, let's say we have an explicit formula presented to us, and we wanted to know a specific term, okay? Because sometimes you just want to predict something in the future. Okay, so let's say your sequence is 2, or common ratio is 2. It starts with a 2, so it's like 2, 4, 6, or 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 9100. What is it? 80? No, 92. Okay, so let's say you're trying to figure out the sequence. Okay, you can use a this explicit formula, you plug in the particular number. So it's asking what's the 11th term in this sequence that starts with 4 and has a common ratio of 2. Okay, so you just plug it in. You're saying a sub 11 is going to be equal to 4 times common ratio of 2 to the 11 minus 1. Okay, and 11 minus 1 really should be in its own parentheses. Okay, so then you go to your calculator. Okay, just like you did before when we did exponential graphs or functions. Okay, and you're going to clear your calculator before you start always. You should be good at this already. So 11 minus 1 is 10, so you're going to write 2 to the 10th power, and you get a number. Okay, and then you multiply that by 4, and then you get 4,096. So you'd write down that the 11th term is equal to 4,096. Okay? Alright, pretty easy, right? Now watch me do number 10. Number 10 is saying we have a sequence that's starting with -4 and the common ratio is -3, which means every time we're multiplying by -3. So the first number is -4, second number we multiply by -3, which is positive 12. Positive 12 times -3 is -36. Negative 36 times -3 is positive 108, right? So it's shifting back and forth between negative and positive, and it's being multiplied by 3. So find the 11th term again. So then you would go to your calculator, and you would write out, you go n minus 1, which is 11 minus 1, which is 10. And then you go -3 times, or I'm sorry, not times, -3 to the power of 10. Okay, and you get this large number, you multiply that by -4, and we get the following answer, -236,196. That is the 11th term. Okay, does that make sense? Okay, and you might say, why do we need to know this? Well, maybe you are a scientist. Maybe you are creating, you are in a lab and you create, you're trying to research antibiotic, and you have to use a particular bacteria that you grow, and you maybe on number, you have a problem similar to number 9 where you have 4 bacteria to start with, and that you know they double every day. So you're wondering, I need to know how much bacteria I have in 11 days, okay? Because I need to have at least 4,000 bacteria. So in 11 days, you calculate how many bacteria do you have? 4,096. Do we have enough bacteria to do our test in 11 days? Yes or no? Yeah, because we needed at least 4,000. Does that make sense? So this is how you would use this. It's similar to an exponential function, right? Because this really is an exponential function, right? Okay, so to your neighbor, explain how do we solve or find a specific number in our geometric sequence. Ready, set, go. Okay, number 11, let's do this one together. Okay, we're doing this one together with me. So the first thing you want to do is write down the explicit formula, but instead of a sub n, we're writing a sub 9, right? Because we're asking ourselves, what is, what is a sub 9 equal to, right? That's the first step. So a sub 9 is equal to our first term of positive 4 times our ratio of -3 to the quantity of n minus 1. And instead of n, we're asking ourselves, we're putting 9 in this case, okay? Simplify. We have, this is equal to 4 times -3. And I'm putting parentheses around the -3 to the power of positive 8. Okay? These negatives can be confusing. The trick here, when we have a negative base, if it's an even exponent, we know it's going to turn into a positive answer, right? Because negative times a negative is a positive, times a negative is a negative, that's odd, times a negative again is positive, right? So what should my answer be right here? Positive, because we have an even exponent. Did y'all get that? That's a little trick, right? So we're going to write that in our calculator now. So we pull out our calculators and we write down -3 to the power of 8. Clear your calculator always when you start. Okay, and we get 6,561, and we're going to multiply that by 4. Okay, which is, what's your answer? Write that down. And then show me your answers. Go. Does that make sense? Okay, now number 12 all by yourself. negative 118,098. Okay, that's your answer. That's it. Any questions on today's lesson? You good? Okay, so what I'd like you to do now is talk to your neighbor. What did we learn? How do we do that? How does this fit in math? How might we use today's concepts in real life?